This week on the Austin Healey channel, we do things the hard way. It's already been a strange week. It feels like Monday, but it's actually Wednesday. I had another video project I was working on. What I thought I would do today is work on this piece. Originally I'd planned not to replace the whole thing, thinking that just the very bottom here was rotted, but as I sandblasted it, some more of it fell apart. So we're gonna have to go up higher than I originally anticipated. It has this structure bent into the metal. That'll make it more interesting because we don't have a seam roller, which is the right way to do it. These pieces on the side here, I did try to order them, but they're on back order. So I'm gonna make them myself. They're pretty simple. So it's gonna be interesting trying to get this correct pattern from like here down, and some kind of strange bends on this. So let's get started. So the first thing I want to do before I start cutting stuff out is to mark kind of where the folds go. Because when I cut this out, it's going to be impossible to remember exactly how this went. So I'm going to push this down and mark that one fold was here, one was here, that these came up to this point here, and this point here, and bottom fold was down here, and this one about here. And then I also need to mark the height that this goes. There we go. And then the bottom is just flush down here. I think that's all I'm going to need. Let's do it to the other side. There we have it taped off. I'm not going to try to do the whole section in one go. I'm going to split it right here where this seam is. It's just, I don't know, maybe it's a confidence thing, but if I screw up on a smaller piece, it's not as costly as a bigger one. So bit by bit, and then I'll just have a little bit to weld here. It's not a big deal. Okay, let's start cutting, I think. Maybe I'll just make it out of cardboard. What do you think? Nah, probably not, huh? I'm not sure how well you can see it, but the indent is right here on the piece I've cut out. I'm going to line it up based on this part here, and then I'll be able to mark where the indent is. It starts out here and kind of goes to there. Looks like 1.25 inches off where the fold goes. So if I get that right, it's about like that. This will be the flat top part, and this will be where it flattens off inside. There's also a rounded corner here. I'm not going to bother drawing it out. Let's put it up against the car and see how it fits. Now for the big question, how the hell am I going to bend it without a seam bender? Well, let's give it a try. My plan is to clamp it between these two. and that'll keep it straight and flat. And then I'll just beat it along here where it goes. Where there's a, when I get to this edge, I'll stick another piece of metal in there to keep it up off the table. Let me clamp it up and show you. There, now I just need to hammer it down so it's to the flush with the table. So now I have to choose which hammer. This one's too pointy. This one is too square in this profile. This one might have some uses, but I think the main one's going to be my trusty old ball peen. I think this was my grandfather's, but I don't know which one. Anyway, let's start some beating until morale improves. I think you can see it best on the back, down all the things and bumps and stuff in place. It's starting to look like what it's supposed to. It's not quite sharp on the curve here. Maybe I'll see if I can sharpen that up a bit. Now I'm just going to try and flatten it down a little bit. I just keep going back and forth to the car. So, it's fitting in pretty good. Everything seems to be lining up. I have extra on this side, I have extra on that side, so I might keep and then make the connection over there. But this side needs to come down now. Yeah, I'd say I'm happy with that. I need to tack it in place before I move on any further. You can never have too many clamps. I shouldn't be surprised by this, but it's nice when things work out. The cardboard template I made for the other side fits over here when I just reverse the direction of the tabs. These bottom tabs go this way instead of that way. It's you know, they're mirror images of each other, so it should work. It's just nice that it does. I haven't talked a lot about my welding technique, mostly because I didn't feel like I knew enough to talk about it until now. There's a few things that I've been doing that are working really well, and I wanted to share those with you. I've come a long way since I've started TIG welding on the Season 1 project. Actually, I remember the very first car that I learned to weld on. It was a theater project for the Des Moines Metro Opera. It wasn't really a car, it was drug across the stage with a cable, but I had to help build it, and I was given the assignment of building the frame. So I was shown some box steel, an old Lincoln arc welder, and given some sticks and about 5-minute introduction on how to weld and said, get to it. So I had to teach myself how to do it. Welding on the floor, in shorts, I think. Not the best experience. I did get the steel, you know, stuck together well enough to get the car drug across the stage. Anyway, after that, I did some MIG welding in a university. They had bought a new MIG welder. It was the first time the shop transitioned you'd be able to do steel from just wood. So that was an interesting project. And then I was at another theater, and I needed to weld some aluminum, and they showed me how to TIG there. Well, the basics of it anyway. So here we are today. Now I'm showing you how to do it. You can see my welds aren't perfect, but they are adequate. I don't want to get into too many details about settings and all that stuff. On my machine, I'm welding generally about 30 amps, and I'm welding 1mm steel. The technique I want to show you is how I tack weld. I've never seen an explanation for this. It's just something that I've developed. It seems to work pretty good. If you have two brand new pieces of steel butted together, you can tack weld very easily, and sometimes even without filler rod. Problem is, with these old cars, the steel, even after you cut it back to solid, you're not sure exactly what you're dealing with thickness and stuff. So you have one side that's really good and one side that's questionable. And often it's very easy to blow through the questionable side and get a big hole. So this is the technique I've developed to eliminate doing that. So let's go over the car and I'll show you. The most important part is to get your metal fit together really well, with very little gap. If you have some like over here, it's going to be okay, but it's better if you can get it straight up and down, straight together. This is filler rod, if you don't know. And the way my technique works, I'm going to show you without sparks or anything. You put the filler rod where you want the spot. You put the torch really close, aiming for the filler rod. You hit the power, you melt the filler rod, and you end up with a little ball right over the seam. Now this little ball is just kind of sitting up on the surface and has almost no penetration. So then you increase the power with your foot pedal until it kind of sucks in. And once it sucks in, you let off the power and let it harden up. And that gets you a tack weld that's fully penetrated, and it protects if there's any weakness in the old steel. Now let's try to do it for real. One of the last things I need to do on each of these edges at the end of the box is to align the curve. This was impossible to do before it was mounted, because you just don't know. So I've welded it here I've welded it on each side. So this is flush and down here is flush. And then the curve just needs beaten back a little bit until it's perfect. I've been doing a lot of welding and I've thrown the word TIG around a lot. So I thought it would be time to explain that to you, tell you what TIG actually means. In this week's Say What? TIG is actually an acronym. It stands for Tungsten Inert Gas. What's that mean? Let's break it down. In here, this is your welding torch, and in here you have this. This is a piece of tungsten. There's many different types of tungsten and they're color coded. This one happens to be gray, but they're purple and gold and many different colors, each for very specific purposes. Gray is kind of a general one. But this piece of tungsten is what gets hot and delivers the electricity to what you're welding. The other part of TIG, the inert gas part, comes from this over here. See, when metal melts, it gets very reactive to what's in the atmosphere. The argon in this bottle flows through the torch and encases the tungsten part in a cloud of gas. So while you're welding, it displaces all the oxygen and keeps your weld from rusting or reacting with the environment. There's other types of welding, MIG, which is metal inert gas, which instead of a tungsten piece, it feeds a wire, your filler wire, through the torch tip. But that's a whole nother thing. TIG is a little more flexible. You can weld stainless steel and aluminum with it as well. That's why I chose it for these Austin Healey projects, because there's steel and aluminum and you need to be welding both. So buying a TIG and learning how to do it allows you to easily switch between aluminum and steel. You can technically weld aluminum with MIG, but results will vary. So anyway, TIG, that's this week's Say What? So now that I have this tacked across the top all the way across, all new pieces, rust free, I've clamped it in place so it's nice and straight all the way across there. I have a ruler that is just like that much too short to fit across there, so I'm using this piece of aluminum stock to check things out. Okay, so with it nice and straight, I'll tack weld this in place. And then finally, to fill this hole, another cardboard template. This was a piece that was on back order. It'd be really simple to make. This back edge here, once I make it out of metal, I'll trim it down so it fits a bit tighter. But that's the rough one. So when this started out as a flat piece, it was parallel. Because of the way it was folded, it makes the sides go like this, which is really interesting because then it allows you to go through in here and cut out enough for it to fit perfectly in place. Okay, so how do I figure out how much to cut off there? With these. I'm gonna go down a bit at a time. So about that much at a time. Tighten this up. And really, just scribe a line following the path. Now grind that off and see how it fits. There, that's already much better. I think I'll do a little bit more just because. Tighten these up a bit. So now that I have this whole thing finished and tacked in place, let's review a little bit. Was this the best way to do it? No. Was it the easiest way to do it? No. Was it the cheapest way to do it? Maybe. What I should have done was just ordered the part and, replaced the whole panel. However, I hadn't ordered it. I thought it was in better shape than it was, blah, blah, blah. So, here I am. I needed to get it done because that's the next step in the process. So it also allowed me to make some parts that were kind of interesting. Making these indentations was it was challenging, yeah, because I didn't have the right tool. But what I did have was a hammer and a piece of angle iron. And it was interesting to find out that that's all you really need. Yeah, having the right tool would have made it simpler, quicker, a little smoother, but let me put it this way. I've been to a lot of castles with my kids over here in Europe. It's something to do on a weekend. But inevitably, the castles have a suit of armor in them. And, the kids love suits of armor. So you go up and you look at these, and they're incredible. They have these wonderful curves and shapes and things. And you go, oh, how did they do that? They didn't have a 30-ton press to squish out a panel. It was all done with a hammer and it'd be probably a tree stump. Maybe an anvil. But it brings me back to the point that we think of steel as being solid and rigid, which in many ways it is, but it's also malleable, which means you can take a mallet and beat on it until it takes the shape you want. It stretches, it compresses, it bends. It's really an interesting material to work with. So was this the best way to go about this? No, it wasn't. Did I get the job done? Yeah, and I'm pretty happy with it too. I think once it's finished welded and ground down and filled in and painted, it will look wonderful. Besides, I think it gets carpet over it. So if you're doing this yourself, you might want to take the easy way. Otherwise, don't be afraid to take on a piece of steel that's funny looking just because you don't have the right tools. You can still do a lot of things with very simple tools.
If you want to come along on the ride as we complete this project, click the subscribe button. If you want YouTube to tell you every time there's a new video, click the alarm bell. Thanks for watching, and your support is very much appreciated.